momentum. P equals mv. So that's what we have to know the velocity. Number 6, this is the tricky part. Calculate the remaining mechanical energy at each point labeled. So A, B is really easy. You didn't lose anything, so maybe you shouldn't pick the first point. So that's going to be your initial potential energy minus the energy lost to friction. Or, and here's what you can do. Take your initial potential energy at the top and subtract from that the length of track to that point. You'll measure it with your string again, times the average energy loss that we calculated in number 5.
Would you measure it from the top to the hill?
I'm sorry, what?
Would you measure the length from the top to the hill?
You measure the length from the start. So if you're going to do point A, that's going to be your first point. You always measure from the start. So we're going to go point A. This distance times the amount of friction lost per meter will tell you how much energy you lost between here and here.
I know what to do.
Now, if you want to go to point C, you're going to wrap it all the way around your loop-de-loop. And now it's going to be that distance times the friction loss, and you subtract from the initial potential energy. So as you go through the ride, your energy should get less and less, right? We're losing it to friction. We're just spreading it out over your ride, so it's more realistic. All right, and I'm almost done. Number 7. For each reference point that you pick, mechanical energy for each point is going to equal the potential plus the kinetic. Like I said, you can calculate the potential. All you have to do is measure the height at that point. So now if I want to do, for my roller coaster, if I want to do my top of my second hill, I can calculate my potential energy by measuring my height. Okay? And what do we know about all this potential energy converts into what type of energy at the bottom? Kinetic. So you could do a top and the bottom of your second hill. So we know that the kinetic energy at any point is going to be equal to the total mechanical energy at that point minus the potential energy at that point, and then we could solve this KE for the velocity. Yeah? What? That's what we did, the amount of friction loss per meter. We did that in question number 5. I'll post this on Blackboard for you.
Yeah. Wow.
Okay, so we did 7.
Yeah.
How do we do that? Here's our super easy formula. Kinetic energy solved for velocity. Kinetic energy is 1/2 mv squared. And there's your formula. So work on that tonight and bring your questions tomorrow.
What about our physicist assignment?
Well, you should have already had that almost done.
How do we turn that into?